First thing that I'd like you to do is to copy this screen, and from that screen we're going to be going into the Boyle problems and then the Charles problems. So turn the recording off and copy this down, and then so the big deal on this screen is that P1 and P2 must have the same unit of measure, as do V1 and V2. They have to be the same unit of measure. So if you start V1 in liters, V2, if V2 was the unknown, V2 would come out in liters. Okay? If you start pressure in atmospheres on P1, it'll be pressure in atmospheres on P2. So in page 422, number 4, this was a typical Boyle's Law problem. You're given 4 variables, or you have 4 variables, P1 and P2, V1 and V2. They can only give you one unknown. There cannot be 2 unknowns, or you cannot solve. There's no way to solve. Algebraically, it's impossible. So, I'm going to read along here. All right, I want you to stop me when I get to something that sounds like a given or a find, okay? If it takes 0.0500 liters of okay, what should I write down?
0.0500 liters of oxygen.
Excellent. Okay. Now, this is the first vessel. The first one I see, I'm going to call it V1. I could call it V2, but I'm going to call it V1 because I just am a sequential kind of person, and I do better that way. Okay? So if it takes 0.0500 liters of oxygen, and I have that gas kept in a cylinder under pressure, were we told the pressure?
Not yet.
Ah, guess what? That's our find. Okay? We're going to fill an evacuated 4-liter. Okay, so what do we have? This guy is V1, the vessel, the first vessel. That's the second vessel, and that's the pressure that we didn't get. See how I'm sorting this out? Piece by piece, one at a time. It gets so much easier that way. Reaction vessel in which the pressure is 0.980. There's our P2. See? And now all we have to do is plug this in. We're going to check it, make sure that V1 and V2 are in the same units of measure, and P2 and P1. Now, they didn't tell us what unit of measure to use. So when I run this through Boyle's Law and I get an answer, what is the unit of measure going to be for P1? ATM, atmospheres. Yes, absolutely. Okay? That's all there is to these problems. Okay, I hope that's helpful. We're going to move on and look at a Boyle's Law, or Charles' Law, I'm sorry. With Charles' Law, we have a different situation, and I'm closing this off just so that we can concentrate on one thing at a time. With Charles' Law, it won't work with temperature in degrees Kelvin, or centigrade, I'm sorry. It has to be in degrees Kelvin. It just won't work. You'll get the wrong answer every time if you use degrees centigrade. So this particular law is direct relationship. Direct means that the two kinds of variables are fractions. Let's look back at Boyle. Notice the difference? They're side by side. They're not fractions. This is the inverse, and this is the direct type of relationship. That holds for all the gas laws. Okay? When I look at this problem, If you'll turn to page 425 with me now. Page 425, number 6, your first homework problem. You probably want to write this down. Start your homework pager. Okay? This is a freebie. As I read this, it says, I have a gas at 89 degrees centigrade. What I do, and I'd recommend that you do, is don't go any further than that. If they give you centigrade, immediately change it to Kelvin. How did I do that? Look over here. Bottom of your backside of your handout for today. Okay, kelvins. To find kelvins, we take degrees centigrade, add 273. To find centigrade, we take Kelvin and subtract 273. Okay? All right? That's all you have to do. When we take 273 away from Kelvin, we get to degrees centigrade. Okay? When we have Kelvin, it's going to be centigrade plus 273. So that's how you deal with those guys. And we're going to look at this little string of calculations in just a moment. But let's get back to our Charles Law problem. Now, I just read the 89 degrees centigrade occupies 0.67. Ah, there's my first volume. That's 7. This guy goes with this guy. You must get the other unit of measure with the same dude. Whatever T1 is, the volume has to be the volume that T1 represents. Okay? The first conditions, which I just showed you as an example with a balloon. Okay? Blown up and not blown up. Now, the next thing is, at what Celsius temperature? Oh, okay, here we go. There's our find. At what Celsius temperature will the volume increase to 1.12 liters? Ta-da! There it is. Now, here is your roadmap, folks. This is big picture stuff. Notice we already changed our degrees centigrade to kelvins. We run the calculation using Charles' law. But it has to be in kelvins. It won't work if you don't. After we get the answer in kelvins, then we're going to change Kelvin back to centigrade because that's what they were asking for here. Okay? Make sense?